In this video, I want to take you through a couple homework problems that you're going to see in your assignments. So this first one we're doing is number 32. That is not one of your homework problems, but I think you have ones in the same section. So in the directions, this is number 32. It says use a graphing utility to graph the region bounded by the equations, which I've done here on Desmos. You can also do this on your graphing calculator. That is no problem. Then it says B, find the area of the region analytically. So that's what we were doing before. Analytically means do it by hand. So to do this by hand, you're going to take the integral of, let's see, what's this point? We can use our graph to find that. From -2 to 2, we want the top curve, which is going to be this blue one. That's the parabola, minus the bottom curve, which is the red one. Okay, and we can do it all in one segment, even though our area is split up into two different parts. Since the blue curve is on top the whole time, we can do this all as one integral. So you're going to do that through analytically. That means by hand. And then part C says to use the integration capabilities of your graphing utility to verify your results. So we're going to use Desmos or your graphing calculator to check this. So in Desmos, if you pull up that keyboard and go to Functions, under miscellaneous over here, you might have to click miscellaneous, you have your integration. So we are going from -2 to 2, and we want to do the top curve, which is the blue one, that's the parabola, minus the bottom curve. Make sure you only use parentheses here. I forgot to close that parenthesis. The first time I did it, I was using brackets, and Desmos got mad at me. And then you have to tell it dx, and Desmos will solve it for you. So when you did this by hand, hopefully this is what you got. Desmos is always going to give it to you as a decimal first, but you can convert it to a fraction as well. Now something else you may have noticed on this one is these two areas that we were finding were the same. So it might have been just as easy to find the integral from 0 to 2 of the top curve minus the bottom curve, and then double that answer. Which would be totally fine. You can do it that way if you know you're working with functions that have that kind of symmetry. And I'll show you that you do actually get. Okay, turn that into a fraction. Oh wait, there went. I forgot to double it. There we go. Okay, so that is also totally fine to do. All right, the other question I wanted to look at is number 58 out of your textbook. So number 58 says, use integration to find the area of the figure having the given vertices. And then it lists out these 4 points. Yep, I have them right. Okay, so this makes some sort of quadrilateral, and we want to find the area of that. To do this, we're going to need the equations of the lines. So first I need the equation that's going to go right here, which is going to be, it has a slope of 2 obviously, and it has a y-intercept of 0. And then I want the equation that goes here, which is going to be y equals slope is -3. Okay. Now, this is going to, if I do top curve minus bottom curve, that'll give me the area of this section right here. So I'm going to go ahead and do that. We will take the integral from 0 to 1 of the top curve, which was 2x, minus the bottom curve, which was -3x. And Desmos is going to tell us that that area is 2.5. Okay. Now, over here we have a different top curve and bottom curve because I'm going to need different lines for those. So I need to write the equation of this line. Let's see, it has a slope, it's going down 4/2. So it has a slope of -2 and a y-intercept of 4, I believe. Yep, and I'm just using the graph to find those things. And then I need this line right here, which has a slope of 1/2 and y-intercept of -3.5. Yep, there it is. Okay. So now to find this area of this portion of it, I'm going to do top minus bottom curve. And from this time, we're going from 1 to 3. So we'll pull this up from Desmos, get our integration from 1 to 3. Our top curve was that green one, -2x plus 4. Excuse me. And the bottom curve is the purple one, 1/2 x minus 3.5 dx. And the area there is 5. So we found that the area of this section over here was 2.5. The area of this section was 5. So the total area of that little quadrilateral we were looking at is 7.5. Okay, so again, that was number 58. You're going to see at least one problem similar to that, and that's what they mean when they say to use integration. You could have done all of that by hand. I just wanted you to be able to see it on Desmos as well.